Hello, my name is Darren Thomas and I am the Director of Educational Research Techniques. So we're going to continue our journey in Unit 2, Best Subset Regression. And we're now looking at dealing with the initial model here. That's what we're going to do. So we're going to do look at the data preparation. There's not a whole lot of data preparation to do with this particular package, or I'm sorry, in this particular data set. And then we're going to look at the initial model. So let's go ahead and go over to R. So we're now inside RStudio, and so of course, there are several packages that we have to load here. Leaps is the package for the best subset regression. ECDAT right here is the package for where the data set comes from. CAR will help us with some of the assumption testing, and so will the LM test package as well. So those are the packages we're going to use. So you go to line 2, press Control Enter, they're automatically loaded. Now, line number 3 is how we're going to load our data. So the name of the data set is fair. And so what we're trying to do here is we're trying to predict or explain marital satisfaction based off of different variables that we collected about faithfulness. So this will make more sense in a second when I run lines 3, and then line 4 will give us the different variables that we have. So we're trying to predict here rate. Rate is just like their satisfaction with their marriage. And we're trying to use number of affairs, how many affairs that a person has had, their job, education, religion, how many children, how long they've been married, how old they are, and even the gender of the person who answered the survey. We're trying to use all these to explain their marital satisfaction. That's what we're trying to do. Now in line 5 here, we have something called the set.seed, and we're going to use this to try to make it so that the results are reproducible, if you will, so that when we run the different packages and things, this will make more sense in a second, because sometimes when you generate things, it'll change. Now, in line number 6, we're just going to take a quick look at some correlations to see if there are any high correlations. And what's happening here is that we're using the core function, and then inside the parentheses, we put the name of the data set, which is fair. And then in the brackets, I put a comma. That first comma, notice how I leave it blank. Let me zoom in for you for a second so that this is clear. So we're right here. So we're using core, and then we're going to use the package fair. And then notice how I put the space, no number or anything, and then a comma. That tells R to use all of the rows in the data set. And then I put a minus and then a C. The minus means don't use everything that I put after this. So what I'm telling R basically is that, look, R, I want you to take all the rows of fair, but I want you to leave out column number 1 and column number 4. That's what I'm telling it. And this C function means concatenate. It means, to combine things together. So I'm essentially telling R that I want you to find the correlation for all the variables except variable number 1 in the fair data set and variable number 4 in the fair data set. And the reason we're doing that here is that if you look right here at our different columns here, our different variables that are available, the first variable or the first column is sex. And the problem with this variable is that it is a factor variable. It's categorical. So we cannot include it in the correlational matrix. So we'll get an error. And then if you count 1, 2, 3, 4, the fourth column or the fourth variable in the data set is the child variable, which is either a yes or a no that they have children. Again, it's categorical. We cannot include that in the actual printout for the correlational matrix. So that's why we did these things here. So when I press Control Enter, but let me zoom out for you first. When we press Control Enter, and then we just go back here like so, we press Control Enter, and this is what we get. And so you can see here that it looks pretty good. Again, I can zoom in for you to make it a little bit easier for you. And so you can see right here that the only correlation that might be a concern is between years of marriage and age. People tend to frequently marry someone about the same age as them, and as you know, they grow old together. That correlation is kind of high, but the rest, as you look, are all low. So which means this is, pretty useful in terms of we don't have a lot of collinearity. We do have some collinearity with years of marriage and age, but for the sake of practicing how to make models in R, we're going to not worry about that too much. So the correlations look mostly okay. And so normally you want to make a histogram of all your continuous variables, but for the sake of saving time, we're just going to look at a couple of them for demonstration purposes. So here we go. I'm going to make this a little bit bigger, and we're going to make a histogram of the education variable. So this is what it looks like, you know, from 10th grade all the way to 20th grade. I guess that's, you know, graduate school. And then here's the histogram for number of affairs that a person has had. You can see most people are, you know, relatively faithful, over almost 500. But a couple people, you know, they've had some infidelity issues, and some people they just can't seem to control themselves. Have quite a few affairs there. And then one more is this is rate. This is our dependent variable, and so you can see here it kind of goes up. It's obviously doesn't have some normality issues perhaps. Now in lines 10 and 11, we're going to look at the categorical variables. And so what you want to do in that situation is you don't want to make a histogram for categorical variables. Instead, you want to count the frequency and get the proportion of each, you know, of each category within the categorical variable. So to do that, if you look closely here, in line 10, we use the prop.table function, and then inside that function we use the table function, and then inside that function we have the actual data set name, fair, and the variable we want, sex. So what's happening here is that first R will make a table where it just counts up how many men, how many women. And then the second function will calculate the proportions. You know, what percentage of men, what percentage of women. That's how it works. So we press Control Enter, and you can see down here that 52.4% of the sample is female and 47.5% of the sample is male. And we can also repeat this process with the prop.table, like so. So you can see 71.5%, yes, they have at least one child, and 28.4 or 28.5 do not have a child. That's how that works. So in general, the descriptive statistics, you know, is pretty much done. We're going to move now to making the model. Now, what we're doing with this baseline model here in lines 14 and 15 is we just want to get an idea of, like I just said, the baseline. What can we expect if we just throw all the variables in there? And then we can compare that to the other models that the algorithm will suggest to us through the best subset regression. So you should be familiar with how to do this, but I'll explain it one more time. We're making an object called fit, and inside that we're going to use the LM function, this linear model, and we're going to use rate as our dependent variable. And then the dot means use all the variables that are available inside the data set. And the name of the data set is fair. So we're using all the variables here. Let me make this a little bit bigger for you because we don't need the pictures right now. Oh wait, did I do something? Okay, hold on. Okay, there we go. All right. So here's our printout. Right here, this should be familiar from the previous chapter. Let me zoom in a little bit for you to make it a little bit clearer. And so you can see right here at the top, we have the formula that we put in, and then these are the residuals. So, you know, the distance from the line, if you will. The minimum distance is, the lowest distance is negative 3.2, the highest is 2.2, the median is 0.2. And these are the coefficients for all the variables. Notice how most of the variables are not significant statistically. So age doesn't matter. You can see the probability is above 0.05, years married. Children, if they have children, that seems to be a predictor for their satisfaction at a significance that is 0.1, not 0.05. Religion does not seem to matter with this data set. Education does. Occupation does not matter, and number of affairs, as you could guess, that has a serious effect on it. So basically what's happened is this: when the number of affairs increases, the rate or the satisfaction with the marriage decreases. As education increases, so also does the satisfaction with the marriage. And also, here's something interesting: when children decrease, when children increase, the marital satisfaction goes down a little bit. So as they have a child, yes, when they have a child, when child goes up 1 unit, marital satisfaction goes down a little bit. The other ones are not significant. And so then we can also look at, let's see here, the R square. So if I scroll down here, And you can see the R square is only 14%. So not the most exciting model, but again, this is just for demonstration purposes. So we now have our baseline. We know a little bit about our data. We know a little bit about what to expect, and we can use this information as we go forward, and we allow the algorithm to produce the other models. So when we go into the next video, we're going to actually start to experience the use of best subset regression and how it works and how it can improve the model, or maybe not necessarily be beneficial to the model. But for now, we have an idea of what to expect based on doing just a traditional multiple linear regression analysis. So I hope that this was useful and insightful for you, and that you're able to get a little bit of an idea of what to expect as we go forward. So my name is Darren Thomas. I'm the Director of Educational Research Techniques. Take care.